Klaus Bergmann had designed skyscrapers in Dubai and earthquake-resistant towers in Tokyo. When his firm won the contract for a new international conference center in Metro Manila, he arrived with German precision, European standards, and absolute certainty that his steel and concrete design was the only safe approach. What he didn't expect was resistance from a local structural engineer named Ramon Cruz. Ramon had spent 20 years researching traditional Filipino construction methods. His proposal incorporated modern engineering with bahay kubo principles specifically, a hybrid design using engineered bamboo as a primary structural element alongside steel. When he presented this to Klaus during the design review, the German engineer's response was immediate and dismissive. "Bamboo," Klaus said with open contempt. "You want to build a multi-story public building with grass? This is a joke." Yes, in Germany, we have engineering standards. We use materials that have been tested and proven safe. Bamboo is what farmers use for fences and peasants use for huts. It has no place in serious architecture. Ramon remained calm, pulling up structural data. "With respect, Mr. Bergmann, engineered bamboo has tensile strength comparable to steel, weighs a fraction as much, and has natural flexibility." That Klaus cut him off with a wave. "I have read these claims. They are exaggerated by people romanticizing primitive construction. When a major earthquake hits, and it will, we are on the Pacific Ring of Fire, your bamboo will snap like toothpicks and people will die. I will not have my firm's reputation destroyed by this dangerous experiment in nostalgia." He pointed at his design, an impressive steel frame building with reinforced concrete, designed to the highest European seismic standards. "This is how you build safely. Modern materials, modern methods, not sticks from the jungle." The committee, impressed by Klaus's credentials and intimidated by his certainty, approved his design. Ramon's bamboo hybrid was rejected as too experimental, too risky, too Filipino. But Ramon didn't give up. On his own time and money, he built a small demonstration structure in Quezon City, a 3-story building, using his bamboo hybrid technique, designed to house a community center. When Klaus heard about it, he drove out to see it, bringing junior engineers to document what he called a case study in how not to build. Standing in front of Ramon's completed structure, Klaus shook his head. "This is criminally irresponsible. Bamboo poles as primary supports, flexible joints instead of rigid connections. This violates every principle of earthquake engineering. When the shaking starts, a building needs to be rigid, solid, unmovable. Your design will sway like a drunk man. It will collapse." Ramon stood beside his creation, running his hand along a massive bamboo column carefully selected, treated, and engineered to precise specifications. "Mr. Bergmann, respectfully, you're thinking like a European. In the Philippines, we've been building through earthquakes for centuries. We learned something different. Sometimes survival isn't about being rigid. Sometimes it's about being flexible." Klaus laughed. "Philosophy is not engineering. Physics doesn't care about your folk wisdom. When a magnitude 7 earthquake hits, your flexibility will be the flexibility of something breaking." He took photos, planning to use them in presentations about unsafe construction practices. 3 months later, Klaus's conference center was nearly complete, a monument to German engineering, with its steel skeleton, reinforced concrete walls, and rigid frame designed to resist any seismic force. Ramon's community center had been open for 2 months, serving the neighborhood. The two buildings stood less than 5 kilometers apart, one representing Western engineering confidence, the other embodying Filipino adaptive wisdom. On a Tuesday morning at 10:47 a.m., the earth made its judgment. The earthquake struck with devastating force, magnitude 7.2, epicenter just 40 kilometers away. The shaking lasted nearly 2 minutes. Klaus was in his hotel when it hit, diving under a doorframe as the building swayed violently. When it stopped, he immediately called his site manager. "The conference center, what's the status?" The answer made his blood run cold. Major structural damage. Multiple support columns had failed. The rigid connections had transferred force exactly as designed, but the magnitude exceeded calculations. Sections of the facade had collapsed. The building was catastrophically damaged and completely unsafe. Repair costs would run into tens of millions. Klaus drove through chaotic streets to the site. His beautiful, precisely engineered building stood like a wounded giant, cracked concrete walls, exposed rebar, entire sections tilted at dangerous angles. The rigid frame that was supposed to resist the earthquake had fractured under forces that exceeded his European-based calculations. Engineers were marking it with red tags, condemned. Almost without thinking, Klaus drove toward Ramon's building. He needed to see it. What he found made him stop his car and stare. Ramon's 3-story bamboo hybrid structure stood completely intact. Not just standing, it looked essentially undamaged. The walls were straight, the roof was level. People were actually inside, having found it perfectly safe. Klaus got out and walked slowly toward the structure, his engineering mind trying to process what he was seeing. Ramon emerged, carrying inspection notes. He saw Klaus and paused, reading the devastation on the German's face. "Your conference center." Klaus nodded, unable to speak. "Severely damaged. Columns failed. The rigid connections transferred force but couldn't absorb it. The building shattered like glass." He looked up at Ramon's structure in disbelief. "How?" "The earthquake was massive. Your bamboo should have." Ramon gestured for Klaus to follow him inside. "Let me show you." Inside, Ramon pointed to the bamboo columns, the flexible joints, the design philosophy. "You were right that this building swayed, Mr. Bergmann. It swayed a lot. People inside felt it moving. It terrified them at first, but that movement saved it. Your building tried to stand perfectly still and rigid against the earthquake, and the earthquake won. My building danced with it. The bamboo flexed but didn't break. The joints allowed movement that dissipated energy instead of accumulating stress. The lighter weight meant less inertial force. The flexibility meant the structure absorbed and released energy like a shock absorber." Klaus examined the connections closely, his engineer's mind finally understanding what arrogance had prevented him from seeing. "This is brilliant. The bamboo's natural properties, the flexibility, the strength-to-weight ratio." Ramon nodded. "My ancestors who built bahay kubo weren't primitive, Mr. Bergmann. They were responding to their environment with available materials, and over centuries, they figured out what worked. A rigid nipa hut would have been destroyed by the first typhoon or earthquake. So they built structures that moved, that breathed, that survived by adapting rather than resisting. I didn't invent this, just combined traditional Filipino wisdom with modern engineering analysis." Klaus sat down, the weight of his mistake pressing on him. "I called your work unsafe. I mocked bamboo as sticks from the jungle, and my building built to the highest European standards is condemned, while yours, using methods I ridiculed, saved everyone inside." Word spread quickly through Manila's engineering community. Within days, Ramon was fielding calls from architectural firms, government agencies, and international organizations. Klaus did something difficult but necessary. He called a press conference with Ramon beside him. "I came to the Philippines believing European engineering was superior, that modern materials and rigid designs were the only safe approach. I dismissed traditional Filipino construction methods as primitive. I was arrogantly, dangerously wrong. This man tried to tell me that Filipino builders had learned something over centuries. Flexibility and adaptation could be stronger than rigid resistance. I didn't listen. The earthquake proved him right in the most definitive way possible. My firm will work with Mr. Cruz to redesign the conference center using his approach. More importantly, we will document his methods and share them internationally. What he has developed, combining traditional Filipino wisdom with modern analysis, represents a genuine breakthrough in seismic architecture." The story went viral internationally. Engineering journals published detailed analyses. Universities began studying traditional Filipino architecture with new respect. Bamboo became the subject of serious structural engineering research worldwide. 6 months later, the redesigned conference center broke ground, a fusion of modern architecture and traditional Filipino principles, with engineered bamboo as primary structure. Klaus personally oversaw construction, now in partnership with Ramon, whose name appeared alongside his on every design document. On opening day, Klaus gave the dedication speech. "This building stands as a monument to 2 lessons. First, that the most advanced engineering sometimes looks the simplest when refined over generations to respond perfectly to local conditions. Second, that the best innovations come from listening to those who've been solving problems longer than we've been alive. The Filipino people have been engineering earthquake-resistant structures since before Europe had steel and concrete. They just did it with materials we didn't respect and methods we didn't understand. That was our failure, not theirs." Today, Ramon's bamboo hybrid design is used in buildings across Southeast Asia and beyond. Klaus's firm, now called Ramon Cruz International, specializes in combining traditional local wisdom with modern engineering, and in engineering schools from Germany to Japan, students study the Manila earthquake as a case study in how indigenous knowledge, dismissed as primitive, can contain sophisticated solutions that modern engineering is only beginning to understand. The German engineer, who called Filipino bamboo unsafe, now teaches why Western engineers need to learn from traditional Filipino builders. And every time someone questions bamboo as structural material, he shows photos of two buildings after the earthquake, one condemned pile of concrete and steel, the other standing proud, built with the sticks from the jungle that proved stronger than arrogance.